In this question, we are given a geometric series, and we want to determine the sum here. So the formula is given by Sn, which is the quotient of a times the common ratio to the power of n minus 1 over the common ratio minus 1. So in this specific question, we are able to answer or put some values to a. Okay, we know that a in this case is 5, and the common ratio, well, if we take any two successive terms, let's take 45 and 15. I know if I go 45 divided by 15, I get 3. So my common ratio is 3. The only piece of information we need now is how many terms we are adding together. And that's going to be given to us by the last term. Now, if you recall, the general term of a geometric sequence is t subscript n. Then I have a times r to the n minus 1. Now my term is, the value of it is 10,935. My initial value is 5, my base is 3, and then I have n minus 1 over here. So if I want to solve for n, I'm going to start off by dividing both sides by 5 here. And off to the side, I'm just going to use my calculator to determine 10,935 divided by 5 gives me 2,187, and that's 3 to the exponent n. So 21,087, is that a power of 3? I have a feeling it might be. So I'm just going to, off to the side, and while I do this, you should be trying it as well. Keep multiplying by 3, and in fact it is. Okay, I have 3, well, that's n minus 1. If I go 3 times 2 times itself, the power of 2, 3, 4, 5. So if I do 3 exponent 8, no, 3 exponent 7. 3 exponent 7 gives me the right answer. Since I have the same base, I can equate the exponents. I'm left with 7 equals n minus 1, and therefore n is equal to 8. Now I want to use this in the formula, so let's go over here and start replacing values. So my first term is 5. My common ratio is 3 to the exponent 8, because I'm adding the first 8 terms, minus 1, all over 3 minus 1. So my numerator becomes, so 3 to the exponent 8, and then subtract 1 is 6,560. My denominator is 2. And if I do the math, I end up with 16,400. And that is the sum of my geometric series.